Wind. Yeah, terror. I mean, terror. Fulton. Wonder hosts. Simpson. Sharif. Where's Sharif? Okay. Sharif. Hello, how are you? Can you hear me?
Hello.
How are you doing?
Good, thanks. How are you, Professor?
Fine, thank you. I'm taking the names. So give me a few minutes and we'll begin. Yeah. All right. See, I have 5 for right now. Let me give me a minute. Let me check my email, make sure that's Watford. Is Watford? What's in it for? Watford. Okay. All right. So we decided to do a remote class today because I got a lot of emails. A lot of you are still concerned about the shootings that happened a few days ago. I mean, last week. Actually, last week. Yeah. So we should have it as a remote class. But next week, we're going to return to our regular class session. So 1 minute, I just want to make sure I have everything ready. Just give me 1 minute. Make sure, see my still be on trying to log in. Okay. Looks like everybody having the information. Good. Excellent. So let's begin now. I will first of all try and show you the announcement I made about this class. You can see it's right here. Okay. About the remote class. Actually, the class is supposed to start by 6, but I was stuck in the traffic. So that's when I sent that message. I'm trying to see all of you here. Okay, I want to see the list. Okay. Everybody's in. Good. Okay, so now this is what you need to complete this week, the assignments. Week 8. Begin reading chapter, although actually I posted this something similar last week. Begin reading chapter 4, which is Introduction to Probability. Then you have 2 assignments, classwork 7, which will be due tonight, and then homework 5, which is due on the 22nd. All right, let's begin. Today, we're moving to a new concept, which is probability theory. The probability of an event occurring simply means the likelihood of that event occurring. So for a given event, the probability of that event occurring is the likelihood that it will occur. So Carissa, I don't know if Carissa, you can see it right there. Carissa. Now, the event can be anything. It might be winning a lottery. Might be tossing a coin and head showing up, It can be anything, really. So the probabilities, the likelihood of a given event occurrence, we use 1 and 0 to express them. If we are sure that that event will occur, we use 1 to represent that. If you're sure that it will not occur, we use 0 to represent that. So the natural question now becomes, how do we compute probability? Before we do that, we first of all need to know how to write it. We can write it as a fraction, for example, 7 out of 10, or as a ratio, 7 to 10, or as a percent, for example, 70%, or as a decimal, 0.70. So let's look at the basic concept. Let's start with the probability experiment. A probability experiment means those chance processes that lead to well-defined results, which we call outcomes. For example, when you flip a coin, of course, you know what a coin is. It's a coin, for example. So when you flip a coin, I have Rion. This is Rion. Okay. Rion, okay, I see it. When you flip a coin, the outcome can be head or tail. See? I don't see here. Flipping a coin is head or tail. If you roll a dice, we all know what a dice is. Like this one here is 6-sided dice. Most of the examples we be using for this class for the probability theory is the 6-sided dice. So for the dice, the outcome can be 1 showing up, or 2 showing up, or 3 showing up, or 4, 5, or 6. Another event is can be buying a lottery ticket, win or lose. If you go for an interview for a job, either you get a job or you didn't get a job. These are events. Drawing a card from a deck, you can get a club, spade, heart, or diamond. You can see the card. I think I have it pasted somewhere. A deck of cards. I should have had one here. Okay. Yep, this is a deck of cards. You can see club, diamond, heart, spades. Okay. So any card you choose can be fall within one of those categories of club, spade, heart, diamond. Now, what is an outcome? An outcome is the result of a single trial of a probability experiment. So, for example, when they toss a coin, the outcome are either its head is showing up or tail is showing up. So that means that the outcome for tossing a coin can be either head or tail. Yeah. Then when you buy a lottery ticket, the outcome can be either you win or you lose. When you take an exam, even if you score 80%, 90%, 40%, the outcome is you pass or you don't pass the test. When you roll a dice, there are 6 possible outcomes. 1 showing up, 2 showing up, 3 showing up, 4 showing up, 5, 6. You know, just like that. Another concept we need to know is the sample space. All these basic concepts, we need to know them before we can be able to understand probability and to solve questions using probability formulas or theory. A sample space, very, very important. Sample space is the set of all the possible outcomes of the probability experiment. For example, when you roll a dice, the sample space is 1, 2, 3, 4, 5, and 6. These are all the possible outcomes for one dice. Okay. All the possible outcome for one dice is just what I just wrote in. Okay. So all the possible outcomes are the sample space. Another one is this. When you your interest is in the days of the week, choosing a day of the week, all the possible outcome will be Monday, Tuesday, okay, Wednesday, Thursday, Friday, and Thursday, Friday, Saturday, and Sunday. So the sample space for days of the week is 7 of them, Monday to Sunday. I think you get the point now. Any question in what I have done so far? Anybody have questions? Okay, I'm still missing 2 people. Yeah, okay, 1 person, okay. Folks. Oh, okay. Now, since there's no question, we can continue. So we have a tree diagram. A tree diagram is a visual way to display the outcome of a probability experiment by using branches that originate from a starting point. Let's see how it works. Look at this question. We can use it to illustrate how to use a tree diagram. It says, find the sample space for the gender of 3 children of a couple. Find the sample space. So you know that gender can be boy or girl. So the first child can be, if you want to use a tree diagram to get it, the first child can be either a boy, excuse me, it's my mistake. The first child can be either a boy or a girl. See, that's the first child. Now, for each of these, from this section, first, for B, we have boy, girl, and G, we also have boy and girl. So the second child can be either a boy or a girl on this side. Of course, for the G side, either a boy or a girl. Okay. That's for the second child. Remember, they have 3 children. So the third child, for each of these, you have to have a boy, okay, girl for this, and each of them will have boy, G, B, G. We have boy, girl for each of them. Boy, girl, okay, boy, girl, okay, they have boy, okay, I'll have girl. So now, let's see the outcomes. Either they have boy, the first child, boy, the second child, boy, the third child, okay? Boy, boy, boy. Or they have boy, the first child, boy, the second child, girl, the third child. Boy, boy, girl. Or boy, the first child, girl, the second child, boy, the third child. Boy, girl, boy. Okay. Boy, girl, boy. Or they have boy, the first child, girl, the second child, girl, the third child. Boy, girl, girl. Or it can be girl, the first child, boy, the second child, boy, the third child, girl, boy, boy. Or girl, the first child, boy, the second child, girl, the third child, boy, girl, boy. Or girl, the first child, girl, the second child, boy, the third child, girl, boy. Or girl, the first child, girl, the second child, girl, the third child, which is gear. So this is our sample space. Now sample space is over here. See all the possible outcomes. So you have 1, 2, 3, 4, 5, 6, 7, 8. The sample space is 8 possible. Oh, excuse me. 8 possible outcomes. Okay. Questions? So no question. Good. Excellent. Now we can use this. This is why you call it a tree diagram. If you look at it, it looks like branches of a tree. So they call it a tree diagram. Now, suppose you want to answer a question using this tree diagram. It says the question says, find the probability that the family has 2 girls and a boy. Now, if you see any couple that have 3 kids, their gender must fall within one of this group. Must. Yeah. So they find the probability that the family have 2 girls and a boy. Now, for 2 girls and a boy, these are the events, the outcomes. 2 girls and a boy. So this one is 2 girls, GGB. So girl B. Okay, comma. 2 girls and a boy. So have 2 girls here, then have 2 girls here, BGG. Okay, BGG. One is boys, girl. 2 girls and a boy. This is 2 girls. This one is 2 girls. And that's it. 2 of them. 2 girls and a boy. Let me make sure. Okay, 1 girl, 2 girls here. And 2 girls here. So that means 2 girls and 1 boy. Oh, and 1 boy. Okay. 2 girls, 1 boy, 2 girls, 1 boy. Yeah, that's right here. The couple have 2 girls and a boy. Yeah, that's the only 3 of them. 2 girls here and a boy. 2 girls here and a boy. Okay. So that means this is the outcome. So that the probability that they have 2 girls and a boy, there are 2 of them, 1, 2, 2 outcomes, 2 out of how many possibilities? 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 possibilities. So we can open our calculator. Let me open the calculator so that we can use the calculator to find this. So let's see where our calculator is located. Okay. Oh, I'm gonna put it right there. Desmos. So that let's share it. 2 over 8. 2 out of 8 is 0.25. 0.25. So we're gonna go 0.25. 0.25. So that the probability that the family has 2 girls and a boy. See again, 2 girls. This is 2 girls and a boy. 2 girls and a boy. So 2, I mean, it's 25.25. How about 3 girls? For 3 girls, there are only 3. See, there's only one that is 3 girls. 1, 2, 3. GG. So the outcome is GGG. Okay. Let me see. So that the probability that they have 3 girls is 1 out of 8. Okay, is 1 out of 8 outcomes, out of 8 possibilities. So that will be, from our calculator, we have, this is 1. So 0.125, and go down and put it 0.125. 0.125. So go and put 0.125 here. 0.125. Or if you like, you can call it 12.5%, if you like. Because remember, you can write probability as a percent. So on this one here, if you like, you can call it 25%. Okay. Any question on this? So no questions. Good, good, excellent. Now, at this point, we're ready to look at other concepts in the probability theory. The first one is events. An event consists of a set of outcomes. Remember, the outcome is a result of a single trial of a probability experiment. Now, event is a set of outcomes of a probability experiment. So there are two types. We have the simple event and the compound event. A simple event is an event that has only one outcome. For example, if you roll a dice and the 6 shows, see? Roll a dice and the 6 shows, see? It's only one event. Roll a dice and getting a 2 is only one event. Getting Monday is only one day in a week. So, you see? The outcome is having one outcome for a simple event. But for a compound event has have two or more outcomes. For example, if you roll a dice and get an even number, getting an even number, when we roll a dice, the outcome can be 2, 4, and 6. See, more than one. Getting a weekend is Saturday and Sunday, so more than one. So we call it a compound event. Then now let's look at more probably other concept. Impossible event that cannot occur. You say that we call it an impossible event, so that the probability of an impossible event is 0. If an event is unlikely, then it is the probability is less than 50% or 0.5. For example, let's say that you're applying for a job that you are not qualified for. So you are unlikely to get a job. So your probability will be less than 0.5. I'll use another example. Let's say that you have a strong immune system, so that your probability of getting COVID-19 is 0.45. That means it is an unlikely event. Likely event have probability that is greater than 0.5. That means greater than 50%. So if you are qualified for the job, that means that their probability of getting it is will be above 50%. So we can now discuss the 3 approaches we use when we do probability. We have the classical approach, or what we call classical probability, empirical approach, or relative frequency approach. Then we have subjective approach. The classical probability, under classical probability, we try to compute the probability of an event using sample spaces. The reason is that we already know the number of outcomes. For example, in a dice, in a 6-sided dice, we already know that it has 6 sides. See, 6 sides. We know that already. The day of the week, we already know that it has 7 days in a week. So we know with the sample space already. So under classical probability, we have a known sample space. How about this? A coin has 2 sides, head or tail. A card, deck of cards. As you know, deck of cards has 52 cards on it. So we know the sample space. So that's what in classical probability, we calculate the probability of an event using the known sample space. And the formula we use for that is probability of event B, the probability of event E equals number of ways event E occurs, or number of outcome of event E divided by the sample space. The second one is one that we call empirical probability. This one, we don't know the sample space. So we have to estimate the sample space by observing the number of occurrences of the event through experiments, then calculating the probability based on using the relative frequency distribution. Okay. Now the third one is the subjective probability. This one we don't use it much because it is subjective. So in this class, we'll be focusing only on the empirical probability and on the classical probability. The subjective type it's not reliable because it is subjective. For example, a seismologist might say that there is 30% of chance that an earthquake will occur in California. It doesn't really, he's just saying from what he feels or what she feels based on what he's seen, you know. A doctor might say that based on their smoking history that you're gonna have a cancer. Well, I've seen a lot of people who smoked for years, they never have cancer. There are still some people that smoke that didn't smoke at all. Yes, they have lung cancer. So it is subjective. That's what we don't use it when we try to calculate probability of events. Now let's do some example. First one says, find the sample space for rolling 2 dice. Okay, solution. Now for 2 dice, we know that the first die has 6 sides. See, second die has 6 sides. So this first die is 1, 2, 3, 4, 5, 6. Second dice is 1, 2, 3, 4, 5, 6. So we make a chart like this. Dice 1 is right here. This is dice 1. Make sure I'm saying this. Now the first dice. So I can say that we have okay. Dice 1. Dice. I don't know how to write with this, but I will try. Dice. Okay. 1. Oops. I gotta clean this. Dice 1. See? See 1, 2, 3, 4, 5, 6 for dice 1. Okay. Now this is dice 2. Okay. Now dice 2 has 1, 2, 3, 4, 5. So now when you toss the dice, the 2 dices, either 1 is showing up in dice 1 and 1 showing up in dice 2. Or it can be 1 showing up in dice 1 and 2 showing up in dice 2. Or 1 showing up in dice 1 and then 3 showing up in dice 2. Or 1 showing up in dice 1 and then 4 showing up in dice 2. Or 1 showing up in dice 1 and 5 showing up in dice 2. Just like that. Or it can be 2 showing up in dice 1 and 1 showing up, showing up in dice 2. Or 2 showing up in both dices. Or 2 in dice 1 and 3 in dice 2. Or 2 in dice dice 2 and 4 in dice, 2 in dice 1 and 4 in dice. Just like that. When you get all of them, you see that how many possibilities? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. 36 possible outcomes. See? For 2 dice, 36. But if it's 1 dice, there's only 6 possible outcomes. Any question on this? Any question? Okay, good, 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 excellent. So then we continue. It says find the sample space for drawing one card from an ordinary deck. See the ordinary deck. You can see the cards, clubs. You have 4 suits: club, diamonds, heart, spade. And each of them have 13 cards. See, club has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Diamond also have 13. So the sample space to get this club is 13 cards. Diamond is 13 cards. Heart, okay, 13 cards. Spade, 13. So we add all of them. We got we're gonna add all of them. 13 added 4 times. 13 plus 13 plus 13 plus 13. So the sample space for this event is 52 cards. 52 cards. Now, I'm sure that by now you have noticed that I've been using an example that involve gambling. Well, the reason is that most of the things we do in probability were started by gamblers in the long time ago, and we were able to use it to win lots of money. But eventually, it was discovered that this principle can be applied to other fields of human endeavor. For example, in paternity tests, we use probability to find out that it's 99.99%. The baby is 99.99% yours, or not yours, We use it in education, we use it in the stock market, we use it everywhere to make business decisions. As you will see, when we proceed, there'll be a time we'll be using it to make business decisions. Yeah. Now, let's look at more examples. It says a card is drawn from an ordinary deck of 52 cards. Find these probabilities of getting a jack, of getting a 6 of clubs, of getting a 6 or a 3. Let's start with the first one. Space, sample space. Let's get the sample space for a card. Like you see, we have it as 52 cards. You see, that's the sample space right there. The sample space is 52 cards. So we're looking for the probability of getting a jack. How many jacks we have here? How many jacks do we have? See jack right here. So you have 1, 2, 3, 4 jacks. See? So that the probability of getting a jack is 4 out of 52 cards. Okay? Which give us you got 4 out of 52 cards. 0.077 rounded. 0.077 when you round it. 0.077, okay. 0.077, or if you like, you can call it 7.7%. See? Now next is, it says, of getting a 6 of clubs. That is a 6 and a club. Okay? So that means you mean getting a card that is a club and have the number 6 on it. Okay? This is the club right here. Only one club have number 6 on it. So that the probability of getting a 6 of club is 1 out of 52 cards. Okay? So that means we go to the calculator, 1 over 52 cards. So we got 1 out of 52 cards. That means give us 0.019. 0.019. 0.019. Or 1.9%. Okay. And the third question is the probability of getting a 6 or a 3. That means probability of getting a 6 plus the probability of getting a 3. Note that this P here represents probability. So for the 6, the probability of getting a 6, you look at the card. How many cards have the number 6 on this? See, these are the cards that have the number 6 on them. There are 4 of them. So that the probability of getting a 6 is 4 out of 52 cards plus of getting a 3. How many cards have number 3 on it? See the number 3. And there are 4 cards with that. 1, 2, 3, 4. Okay. Who's the person that have an American? Okay, never mind. I think I got it. Amaris. Okay. 1 minute. Okay, I want to make sure I got everybody's name. So four cards have that number 3, so that the probability of getting a 3 will be 4 out of 52. So you can now go and put this in a calculator. 4 by 52 twice. So we got 4 divided by 52. Okay, plus 4 divided by 52. It was 0.154 rounded. 0.154 rounded. So we got 0.154 or 15.4%. Okay. 15.4%. Okay. So now we have everything we need. Since the probability of getting this. Okay. Any question on this one? Any question? Okay, so there's no question there. Okay, good. Excellent. So now let's look at this one. Say 2 dice are rolled. Find the probability of getting the sum of 7, the sum of 9, the same number on both dice, the sum of 11. First of all, we have our sample space. Remember, we have this sample space before, this one here. Or we have dice 1 and dice 2. So we can have it, bring it down here, so we can be able to answer that question. See the dice 1 and dice 2. Okay. Now, you see, first one says the sum of 7. Look at the possibility that total possibility. We have the total possibility that if you count the number of possibilities here, like 1, 2, 3, 4, 5, all the way to the last one, we have 36 possibilities. Okay, that's our sample space. Now, part A says find there are 2 dice selected. Find the sum of 7. The one that gives us sum of 7. If you look at here, you can see 6, 1, 5, 2. 6 plus 1 is 7. 5 plus 2 is 7. 4 plus 3 is 7. So these are the ones that give us 7. So I'm going to write the outcome that give us sum of 7 includes 6, 1. Okay. We got 5, 2. We got 4, 3, and 3, 4. 4, 3, 3, 4. Okay, we got 2, 5, and 1, 6. 2, 5, 1, 6. Okay. So this is an outcome that gives us the sum of 7. If you add each of them, you get 7. So how many of them? 1, 2, 3, 4, 5, 6. So that the probability of sum of 7 is 6 out of 36. Because there are 6 of them. 6 out of 36. From our calculator, we can see 6 divided by 36. 0.167 rounded. 0.167. Okay, 0.167 rounded. 0.167. Okay. Next one, we want to find the sum of 9. What outcomes give us sum of 9? Okay. So we're gonna start from here. See, sum of 9. 6 and 3. Okay, 6, 3. Next one that give us is 5, 4. Okay. Then we got 4, 5. If you add each of these outcomes, you get 9. And we're looking for the probability of getting a sum of 9. Then 3, 6. 3, 6. So these are the outcomes from this chart. And that give us 9. If you add each of these, you get 9. And how many of them? 1, 2, 3, 4. Or how many see? 6, 3, 5, 4, 4, 5, 3, 6. Yeah. So there are 4 of them, which means that the probability of the sum of 9, of getting a sum of 9 when 2 dice are tossed, is 4 out of 36. Okay. Okay, we have 1, 2, 3, 4. Okay. So out of 36, you're gonna get 4 divided by 36. 4 divided by 36. 0.111 rounded. 0.111 rounded. That's 11%. 0.111. Okay. So that's give us the sum of 9. The next one is the same number on both dice. You can see them right here. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So the same number on both dice is gonna be 1, 1, 1, 1. Okay. 2, 2. 3, 3. 4, 4. 5, 5. 6, 6. So that how many of them? See, they are the same number. And if we count them 1, 2, 3, 4, 5, so that the probability of getting the same number on both dice, when 2 dice are thrown, it'll be 6 with a 6. And we have it, we have calculated it before, but we haven't have it. Right here, we have it here. We have okay, let me just go and put it on the calculator. 6 over 36. Clear it as 6 divided by 36. 0.167 rounded. 0.167. 0.167 rounded. Okay. But this says the sum of 11. Only 2 numbers give us 11, 6, 5, and 5, 6. So outcome will be 6, 5, 6, 5, and 5, 6. So the 2 outcomes that give us the sum of 11 from the chart, 6, 5, and 5, 6. So that the probability of the sum of 11 of getting a sum of 11 when the 2 dice are tossed is 2 out of 36. Okay. We got 2 out of 36. 2 out of 36. So I'm gonna change it to 2. 0.056 rounded. 0.056 rounded. Okay, 0.056. Okay. And that is how to answer those questions of when 2 dice are rolled. Okay. Any question for me? Any question? Okay. So there's no question. Excellent. Now let's look at this particular one. Okay, let me clear this. Okay. It says a roulette wheel has 38 slots number 0, 0, 0, 1, 2, 3 to 36. So you have a slot that is a number 0. They have one number 0, 0. Then they have that one that are numbered 1 through 36, making it 38 slots. Say half 1 through 36 are red, and the other half are colored black. The remaining numbers 0 and 0, 0 are colored green. Find the probability that a ball lands on a black number, a green number, a 10, and an odd number. Okay. So look at the roulettes. You can see the green numbers here, 0 and 0, 0. You can see the red and the black numbers here. Okay. Now they ask us find the probability that a ball lands on a black number, a green number, a 10, or an odd number. So now let's use B for black, G for green, and R for red. Part A says A part that the probability that it lands on the so total sample space is 38 because you have 0, 0, 0 and 0, 0 and 2 slots. Then we have slots from 1 to 36. So that gives us 38. So that the sample space equals 38 possibilities. Okay. Now, for he said probability that it lands on a black number. So that the probability that is on a black number P equals excuse me. For black, how many black? In fact, as a matter of fact, let me get it this way. Let me do it this way. I'm gonna have black. How many black we have? We have half of the 1 through 38 that is red, and the other half is called black. So that means 18 of them are black. Because 36 divided by 2 is 18. 18 are black. For green number, G equal, it says the remaining ball 0 and 0, 0, 0 are colored green. That means 2 for green. Then for red, R, how many? You got say half of 1 through 36 are red, so 18. So the total or the sample space, we can call it the sample space or the total, equals so we're gonna use calculator to do this. 18 plus 2 plus 18. So you got 18 plus 2 plus 18. 38. So we got 38 total or sample space. 38. So once we have it in this form, we're ready to answer the question. It says find the probability that a ball lands on a black number. So that the probability of black number, P of black number, will be there are 38 black numbers. So there are 18 black numbers out of 38 slots. So 18 out of 38 will give us the probability that it falls on the black number. Okay, on the black number. Yeah. So 18 over 38. We got 18 divided by 38. 18 divided by 38. 0.474 rounded. 0.474. 0.474. Okay, that's answer part A. Part B says the ball land on a green number. There are 2 green numbers, so that the probability of land on a green number is 2 out of 38. 38. Okay. So we got 2 out of 38. So we got 2 divided by 38. Give me 0.053 rounded. 0.053 rounded. Okay. 0.053 rounded. Yep. The answer part B. Any question before I proceed? Any question? Okay, no questions. Then part C says, part C says the ball lands on a 10. So the probability that the ball lands on a 10 equal. Now, look at the slot machine. I mean, what they call it? Roulette. There's only one 10. You can see the 10 right there. Only one 10. Okay. We don't have another 10. So that the probability that the ball lands on a 10 is 1 out of 38. Okay. 1 out of 38. We change this to 1. 0.026 rounded. 0.026 rounded. 0.026. 0.026. Okay. Now, part D says the ball on an odd number. Half of them will be odd number, half will not be odd number. So half of them, that means 18. Half of odd number 18. Okay. So that the part D. D. So probability of odd number okay, will be half, which is 18 over 38. Which should be equal to the calculator. Change this 1 to 18. Okay, so have 0.474 rounded. 0.474. Any question on that? Any query? So yeah, good then. There's no question. At this point, we are ready to review some of the basic rules of probability theory. So I'm going to take you to those rules so we can review it together. Look at those rules, the basic rules. Okay. The first rule, rule number 1 says, the probability of an event E is a number, either a fraction or a decimal or a percent, between and including 0 and 1. So this is how we write it. The probability of event A is greater than or equal to 0 and less than or equal to 1, which means that this means that the probability of an event can never be negative. It can never have a negative value. So if your answer is negative, that means your answer is wrong for probability equations. And it can never be greater than 1. So if your answer is, if you're calculating probability and you got an answer of 1 point something or 2 point something, that means the answer is wrong. So it can never be bigger than 1. Rule number 2 says, if an event E cannot occur, then its probability is 0. So for example, the probability that we will not have a class in the campus, inside the campus today is 0. Because I'm having it here at home, at remote. So in that case, probability of an impossible event is 0. Now, rule number 3 says, the number 3 rule says, if an event E is certain to occur, then the probability is 1. If we know that that event can happen, then we can have the probability as 1. For example, the probability of having a remote class today is 1 because we're having it right now. So another rule is called the complementary rules. we'll come to that, which is rule number 4. We'll come to that in a minute. Let's just work on those good. In fact, let's do it. Do the complement rule with examples. Okay. So I'm gonna take you to where we can start applying some of those rules, the complement rule. So let's start with the complement. The complement of an event E is the set of outcomes in the sample space that are not included in the outcomes of event E. I'll give you an example. Simplest way to explain it is that the complement is the opposite. The complement of you being in a remote class today is not being in the physical classroom. The complement of you standing up, if there are 2 events, standing up and still sitting down, you cannot stand up and sit down at the same time. Either you're standing up or you're sitting down. Now, if you're standing up, the complement is sitting down. If you're sitting down, the complement is standing up. So the opposite, that's the complements. And for the complement rule, we use certain, let's try some example. Let's try some examples here. It's number 6 says, find the complement of each event here. The first one is selecting a letter of the alphabet and getting a vowel. The complement and the answers. I say it's opposite. Selecting a letter of the alphabet and getting a vowel. That means not getting a vowel. Not getting a vowel. So, but you have to list it. The complement will be B, C, D, F, G, H. I is vowel. G, H. J, K, L, M, N, P, Q, R, S, okay, T, V. I'm gonna change this to small t as small. So T, V, W, X, Y, and Z. So not getting a vowel. Okay. So the opposite. So the other one here, see, it says selecting a moon and getting a moon that begins with J. So which means the complement is getting a moon that doesn't begin with J. That means getting answer will be it'll be getting, so selecting a moon and getting a moon that begins with J, not getting a moon that begins with J. So getting February, okay, February, okay. March, April, May, August, September, October, November, and December. See, these are the answers. So then you're doing the opposite. That's the opposite complement. Okay. Any question on complements? Any question? Okay, good, excellent. Now, we can now look at some of the complement rules. First one says, for complement, we use, say, if you want to write E complement, E complement. So this is how we write it, E complement. Okay. You can say the small c at the top, that means complement. So the probability of E complement is 1 minus the probability of E. And then the probability of E is 1 minus the probability of E complement. Okay. Let's see how it works. I say in a lottery game, each player chooses a 3-digit number between 000 and 999. A player wins if his or her 3-digit number is chosen. So find the probability that a player buying a single ticket loses the game. See, they find the probability that a player buying a single ticket loses the game. So winning is the event, losing is the complement. He said, find the probability that a player buying a single ticket loses the game. So you're looking for the complement, basically. Okay. Now let's use W to represent win. So lose is W complement. So we're gonna use the probability of win. W complement will be 1 minus the probability of win. So let's see how this person wins. See, he said that the games requires a 3-digit number from 000 to 999. Okay. So to win, you have to buy one ticket that will win the game. So a player win if his or her 3-digit number is chosen. So that means that the probability of winning is 1, because it's from 000 to 999. That means you have 000, 001, 002, 003, all the way to 999. That means 1,000 digits. So that the sample space, okay, sample space is 1,000 digits equals 1,000 digits. So that the only one, if your number is selected, so that the probability of winning is 1 out of 1,000. See, and that gives us the chance of winning. You got 1 divided by 1,000. 1 divided by 1,000. 0.001. So the chance of winning is very slim. 0 points. So, but we're looking for the, it said here, find the probability that a player buying a single ticket loses. So that we're gonna use the formula for the complement. I mean this formula here. So I'm gonna copy it from here. Okay, and paste it here. Oh, excuse me. So that the probability of losing would be 1 minus the chance of winning. So that means 1 minus the probability of winning, which is 0.001, which will give us 1 minus that. We got 1 minus 0.001. Okay. 1 minus 0.001, because 0.999. That means you are 99.9% chance of losing. 0.999 of 999 or 99.9% chance of losing. So that's one of the ways we use complement. We're gonna do more ways of using it as we proceed. In any case, does anybody have a question on this one? Any question? Yes, so there's no question then. So now, at this point, we are ready to look at empirical probability. Remember, I explained on the previous sections that in empirical probability, we don't know the sample space. So we will estimate it by observing the number of occurrences of the events of interest through an experiment. That means we calculate the sample space by ourselves. Then we can calculate the probability of the event from a relative frequency distribution. So the formula we use under this approach is the probability of event A equals to the frequency of event A divided by the total frequency. Okay, let's see how it works. It says here that hospital record indicate that the maternity patients stayed in the hospital for the number of days shown below. Okay. Okay. They stay in the hospital the number of days shown below. Okay. Now, maybe a shoe. Okay. T. That's T right there. They stay the so now it's a find the following probabilities. A patient stayed exactly 5 days. A patient stayed less than 6 days. A patient stayed at most 4 days. A patient stayed at least 5 days. Okay. So in that case, the first thing is to get the total. We add all these numbers, and you're gonna get this. With this, we can now answer these questions. The first one says the patient stayed exactly 5 days. Okay, solution. So that means that we're looking for the probability that the patient stays 5 days. Probability of 5 days equals C5 right here. How many patients stayed? We say 56. So you'll have 56 out of 127. See? That will give you the answer to that. 56 over 127. So we go to our calculator, get okay. Put our calculator, go out of get 56 over 127. So we got 56 over 127. 56 divided by 127. 0.441 rounded. 0.441. 0.441. So that gives us the probability that a patient stayed exactly 5 days. The second one was to find the probability that the patient stayed less than 6 days. Okay. Solution. Okay. The patient stayed less than 6 days. Less than 6 days. Okay. Equals. Now look at 6 days right here. So you say less than that. So it cannot include 6, but it includes 5, 4, and 3. So that means probability of 5, the probability of 5 days, okay, plus the probability of 4 days, plus P of 3 days. You can see right here, this is 6 days. So 5, 4, 3. They can be 6 days because it says less than 6 days. And that will give us, okay, for 5 days, we got 56 over 127. So 56 divided by 127, okay, plus for 4 days, we got 32 over 127. You can see 4 days and 32. 32 divided by 127. Then for 3 days is 15 divided by 127. 15 divided by 127. So let me write this down so I can get the answer. I can write this down. Okay. Now, right on the back of this, we got 56 over 127 plus 32 over 127 plus 15 over 127. So let's go and put this in the calculator. Okay. So we got already we have 56 over 127 here. Plus we got 32 divided by 127. Okay. Plus 15 over 127. 0.811, 0.811, 0.811, 0.811. Okay. 0.811. So that answered that question. Then the third question say a patient stayed at most 4 days. At most 4 days. Okay. If you said probability that the patient stayed at most 4 days. That means 4 days or less. Okay. This is a solution. Okay. At most 4 days, which means 4 days or less. You can see right here. 4 or less. That means probability of 4 and 3, right? Or you can do it the probability of 3 and 4. Either way is still good. Which is probability of 3, 4. If you like, you can make it 3 plus 4. Okay. Plus the probability of 3. Or I can make it probability of 3 plus that of 4. Just like this one. We started from 5 up. So you can make it 3 plus the P of 3 plus P of 4 plus P of 5. Or you can make it the way we did it, P of 5 plus P of 4 plus P of 3. Still the same thing. So here we have equals for 4, you have 32 over 15. I'm sorry, 32 over 127. 32 divided by 127 plus for 3. 15 divided by 127. 15 divided by 127. So from our calculator, we got this as 0. So 32 and 50. Okay, let's go and I think I have those two already in. I just have to remove one of them. So I'm going to remove this one, and the results will be there. 0.370 rounded. Okay. 0.370 rounded. 370. Okay. That answers that. But this says the patient stayed at least 5 days. At least 5 days means 5 days or more. Okay. Solution: 5 days or more. Yeah. So that the probability of at least 5 days, probability of a patient stayed at least 5 days, 5 days means 5 days or more. See, look, 5 days, at least 5 means 5, 6, and 7. So that means probability of 5, P of 5, okay, plus the probability of 6 plus the probability of 7. See? So that is at least 5. That means 5 or more. That means 5, 6, 7. For 5, I have 56 over 127. Which means 56 divided by 127 plus for 6 days, we have 19 for 127. 19 divided by 127 plus for 7, I have 5 over 127. 5 divided by 127. So let us go and put this in. write it down. I got 56 over 127 plus 19 over 127 plus 5 over 127. Okay. So you got 56. The 56 divided by 127 plus 19 divided by 127 plus 5 over 127. But 0.629, and if when you round it, it's gonna be 0.630. 0.630 rounded. 0.630. 0.630. This is equal. So 0.630. 0.630 rounded. Yeah. That's it for this one. Any question? Yeah. Any question? Yes, so no question. Excellent. Excellent. Now, let's look at more concepts. More concepts. The concepts we're going to examine at this point include mutual exclusiveness, dependent events, and independent events. And then we're going to look for take a look at the formulas that we use to calculate the probability of those kind of events. Let's start with mutual exclusiveness. Two events are said to be mutually exclusive if they cannot occur at the same time. For example, let's say that you have two events, being a Democrat or being a Republican. You cannot be a Democrat and a Republican at the same time. You are either a Democrat or a Republican. So they are mutually exclusive. The event being a Democrat or being a Republican are mutually exclusive. How about this? Getting a 4 and a 6 when a single card is drawn, not possible. If you look at the sample space for cards, you will see that there is no card that is 4 and 6 at the same time. See the 4? This card have number 4. This one has number 6. None of the cards have the number 4 and 6 at the same time. So they are mutually exclusive. So that will give you an idea of what the mutual exclusiveness is. Another example we can use is at an intersection, there are two events. Either you turn left or you turn right, or you move forward. You cannot turn left and right at the same time, or you cannot turn left and right and move forward at the same time. Either you turn left or you turn right, or you move forward. So they are mutually exclusive. Another one is getting a king and a queen and an ace. A king cannot be an ace, so they are mutually exclusive. And let's look at dependent event. Two events, A and B, are dependent if the outcome of the occurrence of one event or the outcome of one event affects the outcome of event B in such a way that their probability changes. For example, if there are two events having good grades and the second event is getting a scholarship, see, when you have good grades, then you get a scholarship. They are dependent events. How about two events, parking in a no parking zone and getting a parking ticket? See, if you park in a no parking zone, next second event is get a parking ticket. Okay, the event, drawing a card from a deck, not replacing it, and then drawing a second card. So if a deck has 52 cards, so if you remove one card and you didn't put it back, now you have 51 cards. So you want to calculate the probability of that card, it will change. It will be different, two different, the outcome, the result will change. So selecting without replacement is a good example of dependent events. Now, let's look at independent events. Two events, A and B are said to be independent when the occurrence of one event does not affect the occurrence of the other event. Or you can put it this way: when the outcome of event A does not affect the outcome of event B. For example, when you draw a card from a deck and then you put it back, if you draw a card, get a queen, replacing it before, and then draw the second card. So now there are 52 cards before you make the draw. You draw the card, you select one, then put it back. So you still have 52 cards. So that when you want to calculate the probability of that particular card, the answer will be the same since you replaced it. Another one is winning the Maryland lottery and winning California lottery. That you win Maryland lottery does not mean that you're gonna win California lottery. See, they are independent. So we have rules that we use for them. For they're what we call addition rule, which you can use for mutually exclusive events. Said the probability of event A or B equals to the probability of event A plus the probability of event B minus the probability of event A and B. Now, the key word is or. Whenever you see the or, event A or event B, that will tell you that you're going to use the addition rule. Now, for the mutually exclusive event, this part will change to 0 because the two events cannot occur at the same time for mutually exclusive events. Now we have A or B. In that case, you're going to be probability of A plus the probability of B. Now, I will usually recommend that students use this one because if they're using it, if the two events are mutually exclusive, this part will, as they put the numbers, this part will automatically change to 0. See? Anyway, then we have, remember the key here is or. Or. So it can be for 3 events as well. But let us just stick to 2 events for now. Then we have multiplication rules for independent events. If the 2 events are independent, then the keyword is and. The probability of event A and event B becomes the probability of event A times the probability of event B. And if there are 3 of them, we will have 3 events, which is the probability of event A and B and C equals to PA times PB times PC. But if they are dependent, the formula will change a little bit. P of A and B equals probability of A times the probability of B given that A have already occurred. So where this / means given that. And if there are 3 of them, the probability of event A and B and C equals the probability of event A occurring times the probability of event B occurring given that event A have already occurred times the probability of event C occurring given that event A and B have already occurred. Now I know that these formulas might sound strange, but you see that when we start using them, they're not that bad. Let's look at one example. It says, at a political rally, there are 20 Republicans, 13 Democrats. Oh, excuse me, let me drink some water. Excuse me. Democrats, then 6 independents. If a person is selected at random, find the probability that he or she is either a Democrat or an independent. See the keyword here, or. That's the keyword. That tells you that you're going to use the addition rule. See the or. So first of all, let us use R for Republicans, D for Democrats, I for Independents. So how many Republicans we have? 20 Republicans. 20. For Democrats, we have 13 Democrats. For independent, we have 6 independents. So we have a total of, I'll write this down. We got 20 plus 13 plus 6. So you have okay, 20 plus 13 plus 6, 39. So the sample space is 39. Sample space is 39. So we are looking for the probability of that if a person is selected at random, find the probability that the person is, that he or she is either a Democrat or an independent. So the probability of Democrats D or independent will become the probability of Democrats plus the probability of independents minus the probability of Democrats and independents. So we put the numbers. For Democrats, we have 13 out of 39. Okay, 13 out of 39. Okay, excuse me. Plus for the independent, we have 6 out of 39. 6 out of 39. So 6 out of 39. Then for minus the probability of Democrat and independent. It cannot be Democrat and independent at the same time. So it gotta be 0 over 39. So let us work this out in the calculator. This will be our last example for tonight. Let's work it out. So we have 13 over 39 plus 6 over 39 minus 0 over 39. Let's go and put this in the calculator, see what it gives us. So we got so we have 13 over 39, 13 divided by 39, okay, plus 6 over 39, okay, plus minus, of course, 0 over 39 give us 39. 0.487, let me write it down, 0.487 rounded, 487. Note that I will usually round to 3 decimal places, but usually you round the number of places that the homework question or the test question requested for. 0.487, okay, 0.487, which is 0.487. If you like, you can call it 48.7% chance. Any question before we round up? Any question, guys?
Can you go back to the calculator for 1 second, please?
Yeah, sure, of course. Yep.
Okay, so you didn't do like parentheses or anything, you just did.
Huh?
You didn't use parentheses or anything.
Yeah, you know, I was using parentheses here just to let me show you why I'm using parentheses. You know, this is not, you know, what you want to write 13 over 39. You're gonna be 13 over 39, but you know, they're only one line. See what I mean? So that's why I'm using parentheses to say, so that you won't get confused. It should be 13 over 39, but I couldn't put that in here, put it the right way. Yeah, so that's why I put them in parentheses.
Okay.
Otherwise, they don't need parentheses really. Like
Thank
to write it the correct way, I have to take you to the other workbook, which is this one, where I'm gonna write use the insert a formula that will give me like this 13 over 39. See? But that will take time. You see what I mean?
you.
That will
Yes.
take us a long time. So that's why, to save time, I'm just putting them here the same way, but I just use the parentheses to show you that, you know, it is actually a fraction. Yeah? Any other question before we leave?
I have a question.
Yes, ma'am.
How did you get the 0 over 39 again? And is that what it always is when we do this equation? Is it going to be 0 over whatever the sample set is?
If it will be 0 if and only if the event is mutually exclusive. Like here, Democrat and Republican. You cannot be a Democrat and Republican at the same time, right? Am I right? Hello?
I'm sorry, yes.
Yes.
Can you be a Democrat and the Republican at the same time?
No.
No.
No, that's why it's 0.
Okay.
But if it let's say I'm looking for female and Democrat, yes, of course you can be a female and a Democrat, right? Am I right?
Right.
Yeah, in that case, it will not be 0. It will be whatever it is given here for female and Democrats. Okay?
Okay.
Any other question? All right, guys, do your homework, and I will see you in the class next week. From next week, we'll go back to the classroom. This is not a remote class, so, but like I said, I got some emails that some of you are still, still have a hangover from what happened last week, shooting at the campus. So I said, let's have it a remote, okay? So
Is this what the classwork or homework assignment is? Is it like this?
yeah, I mean, at the beginning, yeah, the homework assignment is for the whole probabilities. So, but some of them we have not covered yet. That's why I made them due on the 22nd. So that by the time you finish it, we will have covered everything about probability. And if we haven't, because of last week we had a awareness week. So what we did today is what we were supposed to do last week, but we didn't do it because of the awareness week. So if the 22nd, if we haven't covered everything, then I'll extend it more by one more week. Yeah. Just keep doing the one that you have covered in the class so far. Yeah. You're gonna see questions like this on Then the one that are different, just leave them until we cover it in the class. Yeah.
Okay. And will you post this for us?
Oh, you want me to post this? Okay, let me save it then. Let me save it. So I'm gonna because I might forget. Let me see if I can put it right now. So how many people I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think I'm missing 2 names. So I'm gonna post this in after we finish the class. I think I'm missing 2 names. Who am I missing here? So let me call the names I have. So if you don't hear your name, then you can tell me. I got Dominic. I got Carissa. So if you hear your name, you can log out, you can leave. So I got Camille Fulton. I got Rion Harriot.
Here.
So I got Jordan Lewis. I got
Here.
I got Sharif Nagaya, right? Sharif Nagaya. And I got Rachel Simpson. And I got Amaris Smith. And I got Anaya Terrell.
Here.
So I got when you hear your name, you can log out. I will see you next week, except unless you have question for me. Then I got Joaquin Vanderhorst. Then I got Amaya Watson. And then I got Deshaun Winder. I got Rafael Jures. and I got Lane, Thyton Lane. That's what I got. That's what I have, guys. Then I will see you guys next week, okay?
Wait, did you get me? I just wanted to make sure.
What's her name?
Yeah.
Last name Simpson?
Simpson Rachel, right?
Yep.
I got you.
Did you
Thank
get me?
you.
Yeah, what's her name?
Last name Watford.
Hold on. Watford Nakia, right?
Yes.
Nakia Watford, right?
Mhm.
Got you right here. Yep, got you.
Also, I was here 2 weeks ago, and you had marked me absent.
Watson?
this- Watford.
Same here.
Mean Watson? I mean Watford?
Wat- Yes.
So check. I will check. I will check it again. Check the video and see if you are there. Then I will check. Update it. Okay.
Okay. Yeah. I also sent you a message.
About today.
No, about 2 weeks ago in class.
Okay. Okay. But I'm gonna check it and see.
Okay. Thank you.
You're welcome.
I had the same issue too, Professor.
Well, what's her name?
Jordan Lewis.
Jordan Lewis.
Yes.
For the last 2 weeks.
Yeah, the last 2 weeks.
You know, let me check his attendance. I will check the video.
Okay.
If it's good, if it's slow down, I'll update it. All right, guys. Stay safe.
I have a question. actually.
Huh?
I have a question.
Sure, go ahead, sir.
Now I spoke to you before about this, but I came to you really late, so I have like assignments that I couldn't do because I wasn't here for it, and you told me to like don't worry about it, but I'm wondering like are you gonna like excuse that exactly, or you're just gonna like what you're gonna do with that?
So you say you came back from
No, I came to your class, like I enrolled into your class around like September, like early September.
okay, you enrolled late.
Yes. So
What will happen now? When we come, I think I remember I remember what that you telling me that
yes.
when we come back in the classroom, that write down those assignments we are talking about. So let me open it for you. But I want to look at the attendance first. Okay.
And I have another question for you. So last week was kind of a lot going on, and I didn't really do some of the assignments that was due October 1st. And I was wondering if you could let me just hurry up and do that. Like if you could take off
They are still open. The one that is
like for example, like a homework and a test, like I'm talking about that.
oh test. I can't give test back now because it's a test. So it's already passed. So what I can do is November time, middle of November, when I'm looking at the attendance and looking at the grades, then if the attendance is still good, I can say, okay, then you can request for the second chance on that test one, and I'll do it.
It'll be test 1 and homework 3 and 4.
Well, you started late, so I can give you homework 3 and 4. Give me those, write them down, okay?
Yeah, I got it. I'm
Write them
emailing
down minus the test. Write them down so that since you started late, give it to me on next week, then I will put them for you.
Okay.
Don't forget, because if I can't remember, I can't remind you to do that. Okay, don't forget.
I got you.
I remember you told me that you started late. I remember. Yes. What's her name again?
Tayon Lane.
What? Say it again.
Tayon Lane.
Oh, Lane. Yeah, it's
Yes.
true. Lane. Yeah. All right.
Yeah.
All right,
I got
guys.
a question. I got a question.
Go ahead.
Yeah, so I'm missing like 2 class work assignments. I can still turn them in, or
Which of them are you missing?
it's the ones from like the end of September, from like the 26th or the 27th.
Well, you have to. You have to. Is it classwork or homework?
It's classwork. It's the work like we do right here, like we
So
do
how come you
now.
don't do them?
Cause I had to miss that class on the 26th or the 27th because I had like some personal issues.
Okay. See, you know what? We have to settle this in the classroom. Okay. When it comes to the office, we'll talk about it. I look at that. Everything depends on your attendance score. If it's good, I can give it back to you. But let's see in the class though. Remind me on the class, okay? All right.
Oh, Professor, so I have a question about homework. I'm in classwork 5.
Classwork 5?
Yes. So I did do it, but I seen that you said I didn't properly. You didn't give me full credit because I didn't properly answer the questions, and I was wondering what did I do wrong with the
Okay. What classwork is that again?
what classwork 5.
5?
Yes.
Okay, I'm gonna open it now. Let's see.
Okay.
You sure it's classwork 5?
Yes, the most recent one. Yeah.
Okay. Now, what's her name?
Jordan Lewis.
Louis Jordan. Okay, let me move this a little bit. Yep, that's you right there. See? Can you see my screen?
Yes.
Nothing in the screen.
It's not nothing popped up for you.
Now, see if I click on this, just watch. Yeah, you see how it was. See now, I said I won't give you a full credit because you didn't do your work properly. How did you get Q1, Q2, and Q3? I didn't see it here. I just see
Yeah,
that.
everything that I did, I end up.
And you didn't draw this properly anyway. And the box plot, it doesn't draw it very well. That's not if you use a legible ruler and make it like this is like a scale, so it does not reflect what you did. The fact, remember I mentioned it in the class. You have to show me how you get these answers. I can't give you credit for.
So
Matter of fact, I gave you the credit for this credit you have here is for the box plot. It should have been 50. Because there is 50-50, 50 for the work, 50 for the box, but because you didn't draw it very well, that's why you get only 25. This one here, I didn't give you a credit at all because I didn't see any work. I didn't see how you get them.
Okay, so when it comes to the class, I'm like confused. So I go on YouTube to figure out how to do everything, and the way they taught me to do that, they just told me to scratch out. It was a different format.
Yeah, that's another way of doing it, but you have to prove it. So in the class, you can bring the paper, explain to me what you did. If I'm confused, I'll give you a credit.
Okay, I could do that. Okay, thank you.
You're welcome. All right, guys. Bye. See you guys next week.